Pretty hilarious. All right, ladies and gentlemen. So, first thing, I'm just gonna keep making the reminder, making the ask. If you are going to be 18 by Election Day on the 6th of November, please make a point to vote if you have not yet voted. Okay, you can go to the Johnson County Auditor's website if you need information about the candidates. It's right there also. So I just literally Googled Johnson County election 2018, and that's what came up, and it has a list of all the candidates. If you have a strong party affiliation, you can certainly go to the party affiliated website, and that can give you some suggestions as well. You can go to the Johnson County Auditor any day during the week, or a vote on election day, but please exercise your opportunity to vote. There are a lot of people in this country that do not have the ability to vote, so please, if you don't care, then vote for them, because that matters. Okay, that's my first thing. My second plea to you is to make sure that you've signed up for AP exams, regardless of whether you want to or not. Most of you have, but there's a list that I've got of, I think, 6 or 7 of you still that need to make sure that you state on myap.collegeboard.org whether or not you're planning to take the AP physics exam. Okay. If you have questions for me about whether you want to take it or not, I can answer those now. Hold on just a second. In just a second. Or we can talk later as well. But you have to make decisions by Wednesday. Okay. Mrs. Naughton will hunt you down on Thursday if you have not made a choice. Okay. So I'm going to say by Wednesday, make sure that you've made a choice. Payment is due by November 5th. You can pay either online, tinyurl.com/AP payment. You can do a paper copy. It's in the counseling office. If you are free reduced lunch, then you can get the fee waiver. Excuse me, you don't have to pay for the exam. Okay? Questions?
So on the myap, do you just confirm registration? Is that how you...
I have not done it, but many of you have. So Courtney says yes, that's what you do.
Right.
Yeah. And if you have questions, let me know. Yeah, and so you say yes, I'm going to take it, or no, I'm not, right? Or something like that. Yeah. Cool. All right. Any other questions about that? Please make sure you do that. If you have not done it yet, do that today. I will start hunting people down tomorrow because I want to make sure that we get it done. We got emails on Thursday and on Friday and on Sunday, reminding me to remind you. And I was like, I haven't been here for 3 days. Don't hate me. So I told them I would announce it today. So do it today if you haven't done it already. We good? Cool. All right.
Is that it?
Nope. Good try. We've got stuff to talk about. I haven't been here for 2 days, right? We've been together, but not for a little while. You spent some time on Thursday doing a reaction time lab, I believe, right? Where you dropped a meter stick and caught it and stuff. On Friday, I left a problem set for you to work on. And so I'm going to take questions on those in just a minute. I've got kind of an outline of what the test looks like, okay, to give you today, just kind of the highlights, what kind of things are going to be on it. If we have time, we're going to start collecting some data. If not, we'll do that another day. It doesn't matter to me that much. But there will be a test over this stuff tomorrow, okay? So reaction time lab, I know that you turned it in. I have honestly not looked at it at all. Were there any questions or concerns that you had about the lab itself? Did that go okay? Yeah. Sweet. Okay. I usually substitutes write notes it went great or da da da, and they left nothing for me. So I'm like, what's that?
Wait, which one? Both of them?
Either. I didn't get notes from either person.
Yeah,
so
I was pretty apathetic towards the whole experience. So.
Okay. Well, good to know. I will mentally note that. Yeah. He was
like
a warm body in the room to make sure that you guys didn't.
He came and he was like, "Oh, do this sheet," and then he checked out.
Then he drew on his iPad.
Okay. I will make a note of that. Thank you for letting me know. The person on Thursday.
Terrible.
Wait,
on Thursday? No, we love the Thursday.
Thursday person was okay?
She's
I'm recording all of this, right? So watch out. Be careful what you say. Okay.
Harry, you were here.
All right. So reaction time lab we're feeling good about. But she has a bad reaction time, is that what she's saying?
It was 60 centimeters. We tested it with him.
When I used to do this lab way back in the day, when I did it I did it at a boarding school I used to get. And I used to make the students go around and like have different people of different ages do it. We tried to make some sort of like correlation between age and reaction time. It was kind of funny. It never really worked out well, but it was kind of fun to do anyway. Okay, problem set questions. So these are, it's that blue sheet. I just gave one more out. Does anybody else need one? I've got a couple extras if anybody needs one. I am happy to help you or answer any questions from this if you have them. If not, we can just move on to other things. You do not have to turn this in. This is just problems for you to think about, to work on, to be engaged with, but no, I'm not going to grade them. Did you need one?
Are questions like this going to be a test?
So we'll kind of talk about, so the questions 1, 2, and 3 are a little more in depth than what I would ask. I'm going to talk about that in a minute too, but there will be a couple of calculation questions, but it will be like broken down by step, right? Like, so how long will it take? Do you know what I'm saying? Like it won't be like this long and drawn out, if that makes sense.
There won't be a Swedish shot on AP.
There won't. No, I write my Muppet problems mostly for my regular physics kids, but I know you guys enjoy Muppets now and then too. So yeah, that's where they come from. But the problems on the back are you know, the extra ones, the graphing ones are certainly not lots different. Like that's the kind of thing that you might see on a test tomorrow or something like that. Ian, go ahead.
So I couldn't find the answers for like everything else except for 1, 2.
Yep, that's all I wrote out for you because the rest of them are more conceptual. So I didn't want to like write them. That just is more. Yeah. So we can discuss them.
Answers?
Sure, we can talk about them. Should we do that?
Yeah.
Yeah, for sure. Yeah. So if you guys want to get them out, we'll just talk quick. I mean, we've got time or not. You know, like I'm flexible today. Today is my day to help you guys with what you need. So we can talk about B1WWT24. A ball thrown straight upward falls back down to the same height. This is the graph. Is it wrong or right? Wrong, I hear a couple people saying. What's wrong with it? What's that? There's no negative velocity on the chart, so what should it look like? Straight down. So is the first part right? Yeah? And when does it stop being right? There? So what does this represent here?
When it's like going up and then it stops for a little bit before it goes down.
Exactly, yeah. And so as it comes down, now its velocity is negative. So it should go like this, right? One way to notice that is that the slope should be constant because the acceleration is constant, right? It's always an acceleration downward. Is that one okay? Something like that. The next one, graph shown is for an object in one-dimensional motion. The vertical axis is not determined, so it is not labeled. A, if the vertical axis is position, does the object ever change direction? If so, at what times? Or time? What'd you guys say for that one? Where does it change direction?
No. No.
If this is position versus time, so D versus T, where is it changing direction? At 5? So it's somewhere far away from its origin. It goes back to its origin, and now it's going in the negative direction. But that's just like it's going like this, right? Yeah. And then right here, it was going negative, and now it's going positive, right? If the vertical axis is velocity, does the object ever change direction? If so, where?
At 2 and 8.
At 2 and at 8?
Yeah, right?
Mm-hmm.
No.
Because now you've got a positive velocity, positive, 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 0. Negative velocity, negative, 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 0. Positive, 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 positive.
Are we allowed to keep this?
Yeah.
Alright.
Yeah. Yep, I don't want that. That is all for you. Is that one okay? Can I keep going or no? Was that a stop moving this noise or just a noise for fun? I know you do. I just wanted to make sure that I wasn't ignoring a noise that I needed to be acknowledging. All right, ball thrown straight up. Can I have the chitter chatter stop just so that I can hear myself think and hear people better? A student throws a ball straight upward. A friend times how long it will take the ball to reach its maximum height. The student predicts faster things take less time. If I throw the ball faster, it will reach its highest point in less time.
Yeah.
I will tell you, because some of you kind of are giggling, this kind of problem is very, very common on an AP exam. The reason for it, they've done a lot of research into things like this. A lot of times students, if they don't have a good command of content, they'll read an idea, right? A student is saying this, and they'll say, well, that kind of makes sense, right? It's kind of like if you're sitting at your table and somebody says something like, well, sure, that sounds all right, without actually thinking it through. There are lots and lots of questions, excuse me, like this on the AP exam. Well, it'll say a student says this, do you agree or not? Or more often, it'll have like 4 students, right? Student A says this, student B says this. Which of them, if any, is correct and why? Okay? So I want you to kind of get in that habit of paying attention. So you kind of are giggling about this one. In this case, what if anything is wrong with the statement? If something's wrong, tell me how to fix it. If it's right, tell me why. What'd you guys say?
It's wrong.
It's wrong. Okay, so that's the half point out of 7. Okay, it's wrong. Tell me why it's wrong or how we're going to fix it.
Yeah, if you throw it with a higher velocity, it'll take more time and it'll go higher, but it won't take less time to get its pitch because the acceleration is the same, the negative acceleration.
Okay. So you got to tell me a little more, right? So if you say that, I still want to know more. So you're going to
the acceleration due to gravity will be negative 9.81 no matter what, and with the higher velocity, it'll just make it go higher, and it'll take longer since the acceleration is the same.
Okay.
But it won't be faster. It won't take less time to get to its apex.
Okay. Or you can say V final squared equals V initial squared plus 2AD, right? Using something like this, some sort of relationship to actually back up your claim is a very good idea, okay? It helps to support the idea that you have, right? You've got VF is equal to VI plus AT, okay? And you absolutely have those equations, right? And I think I've mentioned that on the actual for real AP exam, you're not going to do a lot of plugging in numbers. You might do a little bit, but not very much. But really, you're going to have to understand, which of these equations does it make sense to use? Which of these things is going to help to support your understanding and support your point? Does that make sense? Okay. Which of those will help you? Which one are you going to use to help support your point? You want to talk at your tables? Why don't you guys talk at your tables? Because I feel like you're a little bit. Go ahead and talk. I'm going to just letter them for you to give you something to talk about. Those are in no particular order, just the order that they popped out of my brain.
It's 0 equals VI negative velocity and acceleration would be the same.
it has time,
Oh.
and it has
Yeah. Because then the time has to be higher to contract.
because of its sprinting thing is that
No acceleration.
we want to show that the ball will somehow just go higher if you throw it up faster, right?
This is a great question for right now.
That's how fast you go. This is just speed and what is.
Or if you speed up.
Trap.
All right. Can we vote? Did you guys identify one of those three equations that you would choose to use?
Hey,
Yeah? Not a voice vote. Let's vote here. How many of you think you would use A?
Going wrong.
How many think you would use B? How many are going to use C?
Oh shit.
Language, my friend. Language.
Sorry.
This is being recorded for everybody. Your grandmother can listen to this, so please watch your mouth. Okay. All right. Or whoever would be offended. I don't know your grandmother, even if she is still with us. But anyway, regardless, we've got three things. What are they asking about here? What is given in this piece of it, in this stuff?
initial velocity.
If I throw the ball faster, so that's like my initial velocity, right? It will reach its highest point in less time. So we care about the time. Do we care how high the ball goes? Does this student say anything about how high the ball goes? All that this student says is that it's going to reach its highest point. However high that is. Because if I throw it, I don't know, like this, it's going to go up like that. If I throw it like that, it's going to go way up higher, right? But does the student say anything about how high that ball goes? No. Only that if I throw it faster, it's going to reach that point. And what do we know about the ball when it gets to that point?
Its velocity is 0.
It stops, doesn't it? So we really know this time, and we really know that here at the highest point, we've got an initial velocity, or excuse me, a final velocity of 0.
You see.
What's that?
No, I was joking.
Did I missed something?
No.
The acceleration due to gravity is the same? Got A, VI, VF, and T? Okay. I can totally understand why a lot of you wanted to say B or maybe even C. Okay? Because you want time and it says the highest point. But in this case, this is again one of those times where you need to really pay attention to what it's saying and think it through. Okay? Does that make sense? So I would, if I was going to answer this question on a test or something, I would probably include equation A and then say something about how at the highest point the velocity is going to be 0. The acceleration is the same in both cases, and so that means that the time is just dependent on VI. Okay, and then tell us how. If VI goes up, and these guys are the same, the one has to happen to T, right? Does that make sense? How are we doing? Is that okay? There's a lot of stuff in there. There's a lot of physics. Not just, psh, you moron, you're wrong. No. But like why and what's going on? Or, sure, that person is right and this is why. Not just sure they sound like they know what they're talking about. Bless you. That doesn't get you any points. Oh my goodness gracious. That was a lot of sneezing happening. Wow. All right. Velocity versus time graphs. This is about direction. There are a lot of graphs like this and there are a lot of things like this. I'm trying to think. On the AP Physics exam, I don't often see direct ranking tasks, but the skills that are involved in ranking tasks exist on AP tests all the time. All the time. Yeah. The graphs show the velocity versus time for boats traveling along a straight narrow channel. Scales on both axes are the same for all the graphs. The boats all start at the same origin. In each graph, a point is marked with a dot. Oh, this is the one we're going to graph, aren't we? Or we're going to chart it out. Is this the last one? Okay. Indicate in the chart if the position, velocity, and acceleration of the directions are negative, positive, or no direction. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 2, 3, 4, 5, 6. All right, so I want you to talk at your tables. And Henry and Isaac, I'm going to have you guys work with this table right up here. Okay, so come to a consensus with that table. We're going to let's call my back table with Rihanna, you're A. Kian, your table is B. Big table is going to be C, D, E, and my friends back in there are going to be F. Okay? Once you've got it, come on up and put it down for me. Oops, I'm going to move this so that I can. So talk to your table.
We're just saying. Wait, okay, so when it asks the direction of the position, is it where it's trending or where it's at?
Positive or negative. Where it is at that. At that.
Yeah, that's what I was saying. It's phrased that it says the direction, the position, velocity, and acceleration directions of the boat.
This
You can't have negative time.
You guys want to check? Kian, are you ready?
What are we writing?
My stylus up there? Oh. Do you want a special pretty color? What's your favorite color?
Blue.
There you go. Just write like pencil.
Yeah, technically, but it's pretty much. Wait, no, it couldn't be.
Your last one.
Yeah, I took position to be. Yes. We should assume that.
Hey, you guys get all negative?
Yes, of course they do. Why would they not? Yeah, what if it's a million, okay? Then they're all positive. Most likely. Actually, there's no number of these, so we don't know about any of these. I don't know. Okay, the only thing we know, we do know velocity and acceleration. That should be a negative. Oh my goodness.
There's no
It doesn't say the origin, it says the same origin. No, the same origin, not the origin. It can all be negative and all be positive, or all be zero.
So at C, so like, so it's like you're walking into a room, you're like, what did I come here for?
Usually
Velocity is zero.
But it's yeah.
Alright, I'm looking for C, D, and E. C, D, and E. If you've got answers for C, D, and E, put them up there for me.
No. Okay, Miss Carmeline, are we assuming all things start at 0?
Did you read the question?
It says at the same origin, not the origin.
Yes, we're assuming it's at the origin of 0.
Okay. Where's the marker?
And there's the stylus.
Oh. Oh no. This is hard to write with.
Good job, Harrison.
It's not even writing. Did I turn it off?
This is when I start like swearing at it, not literally, but in my head.
Why is it?
There you go.
It's so bad.
No, it's not bad. You're just critical.
I can't write with this. It's.
What is that supposed to be? What are they supposed to be?
Minus is.
Are we defining?
Why are it?
Zero. It's like, did it move
You
forward?
can say 0. Hey, that's an option.
I meant going forward. Because the velocity is constant.
So check the others. Check the ones that were not the same one as you. I don't know. Who's C? Are you guys? It's not like I'm C, right?
Yes.
Rockstar, you got this girlfriend.
Yeah, this is a badly worded question. It didn't specify the word or 0. They all could be positive. or
All
negative
right.
position.
Here we go. Let's look at A. Ladies and gentlemen, you're wasting your time, not mine. Part A, or box A, it says that the position is negative. Do you guys agree? What are you looking for position? How do you determine this one?
The velocity before that was negative.
If the velocity before that was negative, always, as long as it was negative at some point, then it's got to be.
No.
No, it would have
There.
Yeah.
And then it stops.
Yeah, so if you have one where, and they don't have one in this one, where it was like this and the point was here, well, yeah, we'd have to do the math and figure out how does this area compare to that area, right? Yeah. But just a note, so you may want to write this down if you were not feeling 100% confident with this before, you may want to just make a note that the position we're going to determine by the area between the line and the axis. Okay. So the area for A, position was 0. How about for velocity? Were you guys A? Why'd you say 0 for velocity?
Because it's the dots round.
The dots on the 0, right? The velocity, those are just values. So you're looking at the velocity value. Yeah. So we're looking for the value in this case. That's kind of a bad arrow. Let me try that again. All right. And then the acceleration. Gunnar, how'd you guys figure out that the acceleration was positive? Yep, you're looking for slope. Awesome. So you guys agree on A? Plus 0 plus. B, they said plus plus plus. Positive, positive, positive.
Wait, what is it?
Negative 0 plus. There's no criticism. Some of us are more used to writing with styluses than others. So oops, not plus, minus. No, it is plus. Sorry, yo. All right. B, do you guys agree with B?
Yeah.
Plus, plus, plus.
Mm-hmm.
C, plus, because everything's above beforehand, right? 0 because the velocity's at 0. Negative because the slope is negative. Yep. For D, you've got negative because the area under the curve is negative. Gentlemen, would you please be quiet? It's really distracting. It really is. The velocity is negative because the point is below the axis. Negative acceleration because the slope is negative. E, we've got negative. Area under the curve. Velocity value is negative. Slope is positive. F, positive, positive, negative slope. Nice job, you guys. Well done. Issues or questions on that? Go.
I still don't understand how to find a position.
Okay, so the position is you're literally finding the area between the line or the curve and the axis. So for example, let's look at this one here. In A, this is your line. Are you with me there? Here's your axis. So I'm going to find the area between those two. So that's this stuff here. Does that make sense? Actually, and you're just going to find the area of that triangle.
So like for one, if the dot was at 4 and then 1, would the position be 0?
If the dot was here, yes. Yeah, that was a really good question. Did you guys hear what Rosanne just asked? She said if instead of the dot being at what we're going to call 2 seconds, because that is kind of how we naturally look at it, she said if the dot is up here at 4 seconds or whatever we're going to call that, then what would the position value be? And the position would be 0. Because at this point then, again, if we think about literally what this is doing, so this object is starting from the origin, okay? It's going negative really fast, and then it's slowing down to 0, right? And then it's coming backwards towards the origin, and that's where it's gotten there. Because the area down here and the area up here are equal. If we had put the dot even further up, and this is why I was clarifying before, if the dot was way up here, even though we've got a negative part down here, we are now, the position is positive because there's more area that's in the positive than there is in the negative.
So you're just comparing the areas then?
Correct. In this, if there's some area underneath and some area above.
So I can see too.
Correct. Yeah, so this is positive area because we're moving in the positive direction. The velocity is in the positive direction. Okay, but then over here, the velocity is in the negative direction. So that means that we're moving backwards. And now we've moved backwards just as far as we moved forwards.
Why is it in the positive?
Say again?
Why is it in the positive direction before?
Because I'm moving fast. So this is like I'm trying to think of a good example. Like, you're about to start a race and you go really fast, right? And then, but you're slowing down as you go that way, right? Or this literally is like me throwing the frog up in the air, right? He's going fast, slows down. He's at the top, and then speeds up.
Good down.
In the downward direction. That's why I said speed. His velocity gets more and more negative.
Kind of. So but
Keep talking. You're fine.
so you're just looking at it this way because I don't know, that's where you're finding your area.
Mm-hmm.
Yes, kind of.
I think so. Can you ask the question a little bit more, something
Yeah.
like concretely, I guess?
Yeah. So I don't know. I just can't really get over because like the slope is negative even from there. If you just stop at the dot, then the slope is still negative.
True.
So
True.
that means that
So I'm going to have you help me out. Can you stand up and put your hand up here? How are your reflexes? They're good? I mean, you've been measured. So why don't you come stand over here so everybody can see? All right. So I'm going to throw the frog up, and you're just going to catch it. Right? I believe in you. Here we go. 1, 2, 3. You with me there? So what happened is that it started with a velocity that was up, and it's slowing down. And assuming that his hand was at the place where it would have started falling again, which may or may not have been the case, right? We have to practice that a little bit and make sure that we had it all arranged. But if his hand was right at the very peak of where it stopped, then that's where it would be a 0. Does that make sense? Yeah. It's kind of weird. It's super weird. Yeah. How are we doing, team? Doing okay-ish? Question.
Can you explain the 0 position again? Like I kind of got it.
The 0 position again.
You said if
Guys, shh.
I mean, I might have not caught it.
No, you're fine. Just ask the question again.
Yeah, so like on A, you said, I understand that the position would be negative because the velocity is negative there. But then you drew another point right there.
I did.
And you said it would be an equal, there would be no displacement.
Correct.
Because
yeah.
they move the same distance both.
Right. So it moved backwards. It's moving backwards, stop. And then it's going to move forwards, stop. And it's going to get to the same spot.
Okay.
And then it's going to keep going.
So from that point onwards, it would be positive.
Correct. Yeah.
Wait,
Let me say one more thing about that. Is that okay? And then is that cool? So if I'm going to take like C. I'm going to draw it down here so I can just make it the way I want it. So if I do this one like that, so my slope I'm going to say is 9.8, right? So this is where it stops. And then if I'm going to try and measure this the same distance here, you're going to have to, bear with me a little bit. Does that look about right-ish? So if we say that this is, whatever, 7 and 7 or whatever, okay? So this would be me throwing it. So this is my velocity versus time. Make sure I'm being clear here. I'm going to throw it up. Then I'm going to let it go down.
Yeah.
Does that make a little more sense?
Yeah.
So at this point here, because this and this are the same area, then anything down here makes him go even further down. Question?
So the position would be 0, right?
At this point.
And the position was all the way down.
Because this point would be like at where my hand is. Right? Hand, and then he's falling from there.
So the velocity is negative when the position is positive because it's like slowing down, right, as it nears the top.
The velocity is, say that one more time.
Oh!
Something good just happened there, but say your question.
So the velocity, what did I just say? So the velocity is negative, right, because it's getting slower as it's reaching the top.
The velocity is positive because it's moving in the positive direction. The velocity turns to negative once it starts falling. Even though the position is still positive, right, relative to my hand. So if I throw it from here, when it's up here and it's falling, its velocity is negative, but its position is still positive until it falls down below. Is that okay? It's not completely convinced there.
No, yeah.
So even if the velocity is negative, like after a certain point, like, is that where your line is? Is that where?
Yeah.
Yeah. So like the area, if you do the area thing, they'll be equal to each other at that point because it's meeting where her hand is, and then after that it would be negative position. Yeah.
And then
The velocity becomes negative when it crosses the axis.
does that help a little bit?
Yeah, I understand that. I just don't understand like the motion of it versus the graph.
Mm-hmm.
I don't know.
And sometimes it's hard to put the pieces together when you're staring at a velocity graph and we're so used to staring at position graphs, right? We're so used to position graphs, which is why I like this, because I like the fact that you have to process one versus another. Yeah.
So for that one with the displacement versus time, it would start at the axis and then go up and then go back down past the axis and then farther.
This one?
Yeah.
Yeah, let's try it. So the displacement versus time graph, much to Harrison's chagrin, is going to start at 0, right? And then if we think about, let's build it backwards, right? So the value here is positive and getting less and less and less and less positive. So that means that the slope is going to be positive and getting less and less and less and less positive, right? And then the slope is 0. So let me draw that first part. Maybe. Okay, so this point here is the same as this point here. Okay, and then from here down, it's negative, and it's getting more and more and more and more negative. So that means the slope here is going to be getting negative and more and more and more and more and more negative. Go, Nick.
So, on the distance and time graph, is the point there at the peak, is that equal to the area of the yellow triangle on the velocity and time graph?
This value, yes. Yes, this D max, right? That distance is equal to this area. Is that what your question was? Yeah. Yeah. How are we doing? It's kind of weird. Good questions, though, you guys. Yeah, good questions.
Wait,
Go.
would you mind correlating that to an acceleration graphic?
I would be so happy to. Thanks for asking. Yeah. So let's do an acceleration versus time graph. So if you got a velocity versus time graph, you're looking at the slope, right? The slope of the velocity versus time graph is going to give you the values for the acceleration. So tell me about the slope for the velocity versus time graph. Negative and constant, right? So that means that the values for the acceleration graph are going to be negative and constant. Slope here is going to be values here. So it's going to live right here. Hopefully at negative 9.81 or not 9.8. Does that match with what you were thinking? Or did that confuse you, Henry?
That makes sense to me.
Okay. Go, Nick.
So for every free fall problem, will the acceleration graph always be the same?
For sure. Yeah. And for every free fall problem, if it's released from rest, the graph will look the same for velocity, right? Yeah, it'll just be that part. And for every free fall problem where it's thrown up and then comes back down, it'll look like that. Yeah. Yeah. These three graphs, boom, 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 they're always going to look this way. Always. Like it's, yeah. Yeah. Being familiar with that would be a good plan. How are we doing? We okay? Okay, question? You sure? Okay, let me know. All right. We've got just a few minutes, I think, right? Yep, just a few minutes. This is what I wrote down about the test. The tests that I have written or that I've given you a lot of times have really been like 2-day-long tests. I'm gonna pare this one down so that it is a 1-day test because I want to make sure that we can squeeze it into 1 day. So I'm deleting some questions from my original test. Okay, this is what I found when I looked through it. And again, I'm gonna like pare it down a little bit, but this is what I saw from what I've used before. One-dimensional kinematics, you've got those 3 equations. Absolutely, you'll get an equation sheet. In fact, I've got them right here. I've got laminated copies, so I will give you my copy. Okay, it's exactly like yours except it has plastic on it. So anything that you've written on your copy, you don't get. But this is exactly the same as the yellow copy that you have in your notebook. Does that make sense?
Okay, but you know how you gave us like a different equation for the first 3?
Yep, so you need to know those. You need to be familiar with how that translates. Yeah.
Makes sense.
Yes. Because this is exactly what you will get on the AP exam. When you go to sit, yes, this one. Advanced Displacement Physics 1 equations. Like this literally will come in your test booklet. Yay, I don't think it'll be yellow, but I think it's green. I can't remember. But anyway. So, I mean, like, that's why I give it to you, right? So that you know and you're familiar with it. So you walk into the AP exam, you're like, oh, I've seen this before. I've been using this all year. So you got those equations. One-dimensional motion, horizontal. One-dimensional motion, free fall. Acceleration is going to be negative 9.8. You can use 10, but here's the thing. If you use 10, just make sure it's clear. Regardless of whether you use 9.8 or 10, I don't care, but make sure that it's clear which one you've used. Okay? They're both fine. So there'll be some problem solving calculations. Again, it'll be multiple steps. So like it'll be like, what's the time? Blah, blah, blah. Like my intention is that it's not a bunch of steps so that you get bogged down. So it'll be very clear what goes where. Okay? For sure there'll be some graphing, some analysis, like either here's a description of some motion, graph it, or here's a graph, tell me what it means. Or here's a graph and here's another graph and how do they compare? How does the motion of this compare to the motion of this? Right? Or all 3, all in one problem, woo! Right?
Thanks, Isaac.
And because AP does this a lot, there is going to be a new concept, and I'm telling you what it is right now so you don't get mad at me tomorrow, okay? But here's the thing. I do not need to have told you this. So you do not need to run to your textbook and read all about air resistance. That is not necessary, okay? It is not necessary to understand the ins and outs. There's not an equation that's hiding in here somewhere that you need to know in order to be successful on that problem. I'm just letting you know. Like I could have said on the first test that we took, new concept, capacitance. Does that mean you needed to know capacitance? Absolutely not. And if you did, I mean, does that really help you on the problem? Probably not. I'm just being friendly today. Oh, by the way, there's going to be a problem that's going to involve air resistance. Unless I cut it, because, I haven't decided that yet. But I kind of like that problem, so I'm not going to cut it. You will not have to do direct calculations or use new equations, but you will have to understand how that might impact things. Yeah?
So like with the problem solving, are you talking about using kinematic equations?
For sure.
Like implementing the situation?
Yep. Yeah. So there'll be a calculation or two to do, right? Yeah. Okay. What other questions do you have about all of that?
I'm spacing what a horizontal motion is.
A car driving, a robot walking, somebody rolling a ball. Yeah. Constant motion or accelerated motion, but on a flat surface. We haven't done two-dimensional motion yet. Some of you are like, I don't even know what that means. I'll say tune in on Wednesday. I got your back.
Will it be less questions than the last test?
It will be fewer questions. Yeah. My intention is to make it a test that is doable in.
All right, so as opposed to like 7
Or something, or they'll be shorter questions. But
If we don't have enough time, is there?
I'll let you work during maybe 7th period or Liberty time. But I'm intending to write a test that should be short-ish. Yeah.
If we don't if we can't do it in the week time or in 7th, do we do it like at the beginning of class this day?
Probably not, but we'll figure something out. Yeah. What else?
Are you going to be here after school?
I will be down doing robotics after school in the makerspace, but if you need me, you can come find me. Yeah. Anything else? You okay-ish? Cool. We've got a few minutes. You've got 5 minutes before the bell's going to ring. So if things come up or you're wondering about something or whatever, let me know. Oh, I was going to tell you because I've been talking about this with my other classes, and I just want to make it really clear. I was debating. I woke up this morning. I don't know if this happens to you. Like you got things that are like going on in your brain while you're sleeping, and you're like dreaming about things that you need to do. And that's how my sleep was last night. It was really quite enjoyable. No. But I was realizing that, oh my gosh, the end of the trimester is quickly approaching, isn't it? So I want to let you know. So we've got, I think, exams for science on the 8th and the 15th. We've got one more little thing that I do want to do. And yes, we are going to have a final exam in this class. The reason for that is because we got to get you ready, right? So the final exam first try is going to be like a third of an AP exam-ish, right? Maybe not quite, but you get the idea, right? And then because we got to build up. That's the goal, and that's the game. What's that?
Will it still be like a one class period test?
We'll figure it out. I haven't written what it's going to look like yet, but I'll figure that part out. But I am going to let you know that there will be a comprehensive final for this class, for sure.
And then
Go.
has AP grading been like implemented to the Power School yet?
It should be.
It is.
It is not?
No.
Oh, it should be. I'm sorry. I will talk to her. She told me that she had done it. So if she hasn't, I will find out why.
Something's not
Question.
going.
It will go in as an actual grade, but it will be adjusted. It will be adjusted. Yeah. The grade. So it's not going to be just raw points.
Oh.
Yeah. It will be. Yes, that's what I mean by adjusted. Yes. What's up, my dear? As soon as I can. Yes. I haven't been ignoring that. I feel like there were a couple of people that did not get test corrections done from the last test. If that is the case and you didn't get them done, not that I haven't gotten them in, but that you haven't gotten them done, please come talk to me now-ish so that we can get that figured out. Okay? All right, I'm going to stop recording this. Bye, friends. Grace, I hope you're feeling better.